All right, let's take a look at example 1. It says find the second derivative, or y double prime, if x to the fourth plus y to the fourth equals 16. So we are finding that second derivative. So what we're going to do is take the derivative of x to the fourth. We've been doing that for a while now. It's 4x to the third plus, now I take the derivative of y to the fourth. It's 4y to the third. Now every time with implicit differentiation, you go ahead and take the derivative of y, you must write dy dx. Is equal to, now this is a huge mistake that people usually make, so be conscious and try not to do this going forward. The derivative of any constant is 0. Overall, it just makes your life easier, it makes simplifying easier, so just remember to take the derivative of both sides of the equation. Okay. Now to find my first derivative, I got to get dy dx by itself. So I'm going to subtract 4x cubed to the other side. So I have 4y cubed dy dx equals negative 4x cubed. Now to get dy dx by itself, I would divide both sides by 4y cubed. And so dy dx is equal to, well, negative 4x to the third over 4x cubed. 4y cubed, but the 4's would cancel. So it's negative x to the third over y to the cubed. So this is my first derivative. You could also say y prime is equal to negative x to the third over y cubed. They're equivalent. Okay, so first derivative, this notation means the same. So there is my first derivative. Now this problem is actually asking us to find the second derivative. So I'm going to go ahead and find the derivative again. So this is notation for first derivative. I'm going to just go right ahead and write y double prime, and then I'm going to find that second derivative. When I find my second derivative, I will need to use quotient rule because it is a fraction. Okay, so y double prime equals quotient rule, low, so we write y to the third times d high. We got negative 3x squared. Low d high minus high, so negative x to the third. D low, the derivative of my low, 3y squared. Now you must remember, you guys, every time you take the derivative of a y, which I just did, you must write dy dx. All over low. So your denominator squared. Okay. And let's just do a little simplifying. So y double prime equals, I'm going to write negative 3x squared, y to the third. Then it's going to be plus, and usually you guys, you write the constants in front. So I'm going to have 3 x cubed y squared dy dx all over, I'm going to write y to the sixth. Okay, power to a power. Now from here, this is not your final answer. Typically, if this shows up on an exam, it would say in terms of all x's and y's. Okay, so it means there can't be this dy dx listed here or left here. So we're going to go ahead and take care of that. The way you do that is, well, this right here is what dy dx is. Dy dx equals, so I sub that into here. Okay, so I'm going to rewrite it with that substitution. So I have y double prime equals negative 3x squared y to the third plus 3x cubed y squared dy dx. So I'm plugging this in for dy dx. So I have negative x to the third. What's going on? There we go. Negative x to the third over y cubed all over y to the sixth. And now from here, I am just going to go ahead and simplify this part. I'm going to do like more than one thing at a time. Okay, this is all my numerator, so I'm going to write this. And at some point, I'm dividing by y to the sixth, so I'm going to multiply by its reciprocal. So y double prime is equal to, I would have negative 3x squared y to the third. Now here, it's a positive times a negative, so I'd have negative. I would have 3. X to the third times x to the third becomes x to the sixth. And now my y's, I have y squared over y cubed. So that would be over y. Okay, when I combine them, bring your smaller exponent to your larger. And then I'm going to multiply by the reciprocal of this one, so it's 1 over y to the sixth. Okay, now from here I'm going to distribute this. So y double prime equals negative 3x squared y to the third all over y to the sixth minus 3x to the sixth over y to the seventh. Okay. And then from here, I would go ahead and just reduce the y's here. So one valid answer, one good answer would be negative 3x squared over y to the third, okay, when I combine my two y's, minus 3x to the sixth over y to the seventh. Okay, so this is one good answer. This would be a totally acceptable answer. Or the other answer would be to put these two as one fraction, okay? To get a common denominator, I'd times by y, top and bottom. So your other second derivative answer would be negative 3x squared y to the fourth minus 3x to the sixth, all over y to the seventh. That would be your other answer choice, okay? Both of them work out, but there is example 1.